So it's about 3 years ago, I remember being approached and asked if I wanted to work on a little-known IoT solution. And of course, I'm a petroleum engineer by trade, and quite foolishly, I said yes, right? I spent the next several weeks of my life frantically searching all the terminology and language that you guys use. There's a lot of acronyms, and it was kind of traumatic. But what helped, right, was that I have this firm belief that we should live life as students. And it's fitting that I work for Castrol because that's our origin story, right? Over 125 years ago, our founder, Sir Charles Wakefield, looked across the technological landscape of his time, right? And he saw advancements in machines like the automobile and the airplane. And he recognized the deficiency, a gap, right, in the lubricant performance for that equipment. And he found out through his research that if you added a bit of castor oil to the formulation, it dramatically improved the performance of the lubricant and the wear protection. And that product was branded Castrol. And from that moment on, innovation and R&D has been at the heart of our brand. So I'm here today with my colleague Norden to share our learnings about how at Castrol we are continuing on in that spirit of innovation, applying with the latest technologies like industrial Internet of Things. So as with any innovation, we started with the customer, industrial manufacturers. We surveyed over 1,200 industry leaders and decision makers to get a better understanding of what their level of adoption was for IoT and big data, and to see what their perception was on what their drivers and barriers are. Now, right, this isn't new technology. It's been around for quite a while. It's becoming more and more integrated in our consumer goods. And yet it was interesting to see that the majority of them, over 75%, identified their level of adoption as just emerging. And less than 20% identified it as established. And what's even more telling, that's a barrier to that adoption, is that nearly 50% said the benefits of IoT and big data aren't clear. What this tells us is industry wants to move in that direction, but isn't entirely sure how it will impact their manufacturing process and deliver value. So Castrol, we wanted to provide a solution to make this transition easier for our customers. And we get it, right? I mean, the lists of opportunities to deploy IoT into a facility are endless. I mean, even looking at this list of the top 10 IoT applications alone gives me anxiety, right? It's overwhelming. There's asset tracking, inventory management, energy management, the list goes on. And so if I'm feeling anxious and overwhelmed by this list, I can only imagine what our customers are experiencing when they're trying to determine where they're going to deploy capital investment to have a greater ROI in their facilities. So at Castrol, we decided to focus on two topics: predictive maintenance and remote monitoring. Why? Because on face value, the benefits case stacks up. Exploring predictive maintenance and remote monitoring into a lubrication offer could help extend the machine life, extend lubricant life, reduce downtime, which reduces operational costs. But it could also help Castrol and our customers collect large data sets to drive and inform future innovation. Now, the topics of lubricant management and predictive maintenance are something that I'm quite familiar with. For Castrol, I'm in the industrial sector as an application engineer, and I spend the majority of my day working alongside our customers, recommending the right lubricant for their application and quickly resolving issues if they arise. And my colleague Norden here.
Hello, everyone. I'm Nordin Taj. Like Adam said, he works with the customer, he finds use cases. My job is in architecture. So whenever the use cases comes in, my job is to convert that into technological solutions. So I'm part of a strategy and architecture group, and I've been working on a lot of projects related to intelligent operations. So I'm leading all architecture-related stuff where we bring value to the customers.
Yeah, thanks, Jordan. Yeah, he's the smart one. I just deal on the front lines, right?
He's just joking.
And look, we've been doing this for 125 years, right? Expanding our expertise into a variety of environments, from the land, sea, air, and space. And it makes sense. I mean, each of these environments has critical assets that require high-performing lubricants to protect them. I mean, proper lubrication plays a large role in reducing mechanical wear and premature failure. In fact, 70% of equipment failure can be attributed to improper lubrication. And yet, lubrication accounts for only 3% of operational costs. It's through our proven technology we've been able to serve such a broad range of customers and applications. At the same time, we're very aware of what lies ahead and where industry is now. Continued cost pressures, aging machines, and ultimately, the need to demonstrate added value to our industry partners. This is why we're on a journey to expand our offer from lubricants to lubrication. From selecting the right product via Castrol consultancy with someone like myself, to monitoring the health of the lubricant via the lab-based sampling analysis. Embracing IoT has allowed us to change traditionally manual tasks, such as oil sampling, to become automated and diagnostic through the use of sensors and data visualization. The goal, by embracing remote monitoring and predictive maintenance, is to reduce the failure development period at the machine. We can do this by shifting from manual oil sampling, just seen on the graph here below the real time, to an automated oil sampling, which provides our customers with near real-time measurements of key parameters of their lubricants. We can set up alert configurations where they're notified if a critical limit is surpassed, allowing for timely intervention to reduce damage and wear to the machine. Our new connected offer that's being trialed around the world is Castrol Intelligent Lubrication Solutions. It brings together our core offer, lubricants, with consultancy and smart technologies like smart monitoring. Now, what does this look like at a facility? So the first step is a Castrol representative like me would go on site to conduct a survey. We evaluate the asset, collecting key details that drives the configuration of the hardware. There's a multitude of sensor options that are available, from refractometers, concentration, pH, viscosity, wear debris. It's kind of a customizable list, right, that's very comprehensive. Once that hardware is configured and shipped to the facility, Castrol works alongside the customer to install it in line at the machine. From there, it's connected to the network via either Wi-Fi, LAN, or cellular modem. The preferred route that we use currently is cellular. The customers are a lot like me and try to avoid the IT department like the plague. There's a lot of approval processes, and we get it, right? There's data security risks, but the cellular modem route allows us to kind of mitigate that. Once the data is being fed online to our BP IoT platform, the customer is able to visualize all the parameters that are coming through. We have a red, amber, green status listed to key parameters so they can clearly and visually see where they are at. Additionally, they can dive into the data and see historical trends on how those parameters have performed over time. And we set up alerts configurations through email, text, or even on-site visually with a light, notifying them if a critical limit is surpassed, which allows for the on-site engineer to make timely interventions and prevent and mitigate issues. Ultimately, collecting all these large data sets allows machine learning to digest the data, gain insights, and drive future prediction models. The purpose and intent of this is that customers are now capable of being more proactive in how they approach their maintenance tasks versus the reactive model that many of them see today. Now, everything happening in the background in the architecture, that's the stuff of my nightmares. So I'm going to allow my colleague Norton here to give you a little bit more detail on that.
So now we're talking about under the hood, Adam explained exactly how things happen at the front end. So the back end, how we build the solution. So what we have done actually as a deployment, we have sensors, to measure different parameters. For example, the water content, the pH value, TBN, all those other, whatever parameters that we want to measure. We have sensors for that. Those sensors are deployed at the plant level in the lubrication, where the loops are working in the real-time scenario. We install those sensors, and the sensor starts collecting the data. So we have installed, so we have an edge-based solution. So we have a network gateway that's installed, you can see at the site, where all the data is being collected, and we do the pre-processing of the data at the edge. For example, if we need to convert some protocols, for example, if the sensor is sending data in OCAN or OPC-UA or any other protocol, and if we wanted to standardize it, so what we do, we convert that as a converter at the edge. And then we also do the sequencing of the data. When the stream is coming in, for example, it's coming in at every second, so we don't want the oil degradation doesn't happen at a second level. So we wanted to consolidate some of the data so that we can send relevant information to the cloud. So we do some aggregation at the edge level. And then we have some kind of a certificate. We wanted to securely send the data to the cloud. So if you see on the right-hand side, we have an AWS cloud. So we securely put the certificate on the data, encrypt the data, and then we send it to the cloud. As soon as it lands in the cloud, it gets into an IoT core. An IoT core is like a rule-based engine. We have streams coming on from different sources. Multiple plants, different types of equipment is sending data. So rule-based IoT core, it drives where the data needs to send, what was the subsequent process the data has to go through. So if you see from IoT core, it goes to the Amazon Kinesis, where we are doing some aggregation of the data, some enrichment of the data. And then we also put some kind of a limit. For example, the data comes in, a water content comes in, or pH value comes in. Our application engineers and technical services engineers, they determine what the upper limit and the lower limit of those data value is. So we embed that information into the data. So now we have a data, synchronized data in MQTT format. We have an upper limit and a lower limit. And then we send the data to IoT Sitewise, which is another AWS product, where we have different hierarchy by the plant. We can detect where this data is coming from. And then on top of it, we have built an app services, web app application, where we are displaying data, just like what Adam showed before, how the data is coming in. So all this data shows what the data looks like. Is it within the limit or outside the limit? And then what we do is actually we determine if the data is going outside the limit. We also determine if it's a blip or it's a real consistent, outside the limit. And then we send the notification. So notification goes to the user and the plant personnel that this data is out of the limit and it needs some action, So they come in and remediate whatever the issue is. So this is overall, the IoT solution. This has been deployed to our customer side. And then next slide, I'll talk a little bit more about what our future plan is.
And I'm going to hold him off for a second. He's got to wait 2 more slides. So look, up until this point, right, we've been talking a lot about what's the model that we've built, what type of service we're going to provide, right, for our customers to help adopt this type of technology. But again, we're missing the big bits, right? Like, clearly, they don't see the benefit. They don't see the value. So we've put together and compiled 2 case studies on real trials that we have happening out at our customer sites. So the first one here is a European auto component manufacturer. And historically, they had an issue with water contamination on a CNC machine that was using a straight cutting wheel. And so you'd go, why does that matter? Well, water contamination in a straight cutting oil can cause the additive packages to drop out. This reduces wear and EP protection. They start breaking tools. They start having bad parts. It's a costly event, right? And so they tasked Castrol to come and help them solve it. So we conducted an on-site survey, and we recommended the Castrol Intelligent Lubrication Solutions offer. We connected a sensor to the machine, and after we got it going, the sensor picked up a water contamination event that continued to grow on the graph. Now we have two limits set up, right? So there's a warning limit, which is like a, hey, go look at it, and a critical, which is like, you should really go look at it. And so the water contamination crossed the warning limit, sent an alert to the customer, and they're able to go quickly to the machine, find the water contamination source, shut it off, and then connect a vacuum dehydrator, which will evaporate the water out of that straight cutting oil. So this single event, right, saved the customer from having to dump, clean, and recharge that system, which is a $17,000 cost savings in lubricants. Additionally, it saved them over 10 hours right in downtime. And so downtime is one of these soft costs we don't think of. But for this customer, they clocked that at $65,000 an hour. So this single event has paid multiple times over what the solution costs. Now the second one is a US steel manufacturer located in the Southeast. Again, they also had a history of water contamination, and this is on a gear oil central system. So it's a 2,000-gallon system that feeds centrally lubrication to 4 different gearboxes in their rolling mill. So this is a critical asset, right? If one of those gearboxes fails, that entire value stream is down. And for a lot of steel mills, their downtime costs are generally $300 or above per minute. So they don't have time for things to break. So they reached out to us to provide a solution, and again, we recommended the Castrol Intelligent Lubrication Solutions offer. Sensor was connected, and as you can see from the graph, shortly after that occurred, they experienced a water contamination increase, right? And that happened on a Sunday night. So early Sunday morning, the reliability engineer came to the facility, saw the email alerts on his computer, quickly went to the site of the issue, identified they had a burst water hose, shut that off, and connected a vacuum dehydrator. Now, on the graph, it's showing you there's 3,000 ppm of water that was detected. So that's like 0.3%. But this is a 2,000-gallon system, so that's 60 gallons of water, right? And I don't know about you, but water is an awful lubricant. Like, it's terrible at it, right? And so at this level, bearing life and a component life is dramatically reduced to like 50% of its expected lifespan. And so by being able to alert them, allow them to act quickly, they're able to remove the water from the system in less than 48 hours. So this had a huge savings on their component and bearing life. And so sitting with the customer, we calculated this event to be a potential cost savings of $100,000. And after this event, since the sensor's been installed, they've had 4 more recurring events just like this. I mean, that's $500,000 in cost savings and cost avoidance that they've experienced from this single IoT technology. And so I'll hand it back off to Norton to tell you about where we are and where we're going.
So as you guys know, so the future is, artificial intelligence. So right now, I would say that we are at preventive level. We are going to predictive level. So what you saw today is that we have identified the issues, and then as soon as we find the issues, we solve the problem. So our next level is that we wanted to identify issue ahead of time so that we can prevent it. And that's only possible by using big data, a lot of data. So what we have done is that we have created a data lake. So we have an enterprise level data, and these are the industrial level data. So we have a lake where we're consolidating all the industrial data, and then we have an enterprise where we have, for example, the product data, we have the customer data, lab data, all those data is there. We're trying to bring both data together and create some kind of futuristic analytics out of that. So what we have done so far is that we have started putting a machine learning model on the industrial data. So all the data that's coming in, we are trending it, we are harmonizing it, and we are predicting it when the machine's going to fail so that we can do a preventive kind of a resolution on those data. And in future, what we're going to do is we're going to put more artificial intelligence into it. Using Gen AI, we wanted to predict, and also not only the predict, but we also wanted to understand the root cause of the issue based on the past history. So whenever there is an anomaly happens, we will be able to find out what caused these anomaly existed before and what caused it, and send the report to the TSEs so that they can take appropriate action, to prevent it. So we have done anomaly detection, we have done asset tracking reports, and we have done a lot of other reports that we are doing using the Gen AI so that we can start making, efforts from our side to solve the problem.
Thank you. Yeah. And look, I mean, clearly we've identified that there are a lot of challenges, right, around better decision making and trying to convince our decision makers that there's real value in adopting things like IoT. I mean, customers are experiencing it, we're experiencing it. It's not unique to Castrol. My thing's messing up. But, right, ultimately, there is value in it, and working alongside, running trials like this, and continuing to leverage our experience that we have with lubricants towards this offer, we think we can build something that's very unique, that's going to assist the customer in adopting this technology into their facilities and driving and delivering real value when it comes to cost savings. And so again, we thank you for your time, and we appreciate everyone being here, and we want to open the floor to questions.
Thanks, everyone.
Fantastic presentation. It's awesome.
So we are here if you have any questions, technical, business, solution-wise, anything.
So I have a question. So I have in the end you were talking about anomaly detection and you said using Gen AI. So can you elaborate?
Anomaly detection is happening, but Gen AI, what it does, we anomaly to the root cause, So it goes into the system and it finds, this anomaly happened and that was the root cause.
So it's extraction. Extraction of the knowledge from your document
exactly.
repository.
So we have uploads. We upload all these documents. The product-related information. The failure information and all that. And the system, the Gen AI actually goes and reads everything and finds and gives
the
the answer.
extraction and matches that.
Yes. Exactly.
Awesome. Thank you.
Yeah, my question was kind of along those lines as well, where you're looking at, you guys are involved in almost every industry when it comes to lubrication, but being able to take that data set from multiple customers and offer that through your AI package for I do a lot with diesel engines, where it's, would you be able to in the future offer that IoT package that allows me to have a sensor on the diesel engine monitoring the oil and know, okay, is it running rich, is it running lean, are you lugging it down, all those different things that contaminate and degrade oil that indicate a problem somewhere else in the engine.
I think that we already offered that, right? Well,
Yeah. Go ahead.
No, you know more about it than I do.
So we do this, So this solution that we talked about, it's deployed in our customer side. It's not us. So we work with, like Adam, he works directly with the customer. So whatever the issues are, whenever there is some other use cases that comes to our mind, we are able to support that and be able to, develop solutions. For example, it's all sensor-based, right? The data is collected through the sensors. If you wanted to test something we don't have a sensor for right now, but there is a sensor available, our platform will be able to, detect that parameters and ingest into our platform, and then we can definitely be able to embed it into the existing solution and be able to tell you, what the issue is.
I'll add to it real quick. Yeah, and I think to be more specific, right, to build on that towards diesel engine applications, our heavy-duty side they actually have a sensor offering that is used for on-road fleets and things like that to monitor the lubricant health and provide valuable data feedback. Look, I'm not super familiar with it, right, because I'm on the industrial side, but if you want to hang out after this, we can have a deeper conversation, and my colleague Dave might have some information for you that can help you with what that looks like.
Awesome, thank you.
So one more thing that I wanna talk about here. So we also have a solution for predictive maintenance on the pumps. So we are able to collect a lot of data. For example, the temperature, vibration, the voltage, the inlet and outlet pressure. So a lot of parameters. We have capability that we can ingest all these data, and also connect this to the physics model that comes with the pump. And we will able to use the AI model to predict when the pump's going to fail. So we have been working with different scenarios using the same technology that we have.
Hop on up here with us. Come on up here, like.
I looked at your architecture diagram. So you were using the Greengrass edge brokers, sending the data over MQTT to your cloud. So does it mean like your preventative maintenance, your notifications is dependent on internet connection, or is this solution residing on the edge so that the factory flows don't depend on internet at all?
No, so notification service. So Edge, we are just collecting the data. We are processing the data. Very little processing of the data. Once it gets to the cloud, it's the notification and everything is happening through the cloud from AWS. It's not happening at the edge.
One quick build on there is our devices have visualization on them, right? So if it goes outside of a limit, there's a red, yellow, green, and the data is visualized on a screen on this technology. But again, like you're not going to get an email alert if there's not a network connection. But we do have a safeguard there where we get fed the information like on a 6-hour basis on what machines are online and offline, so we can reach out and mitigate any issues they have with modem connectivity.
Yeah, if there's no network connection, definitely that's not going to happen. Yeah.
The reason why I ask, most of our plants are remote locations and they have very poor network coverage.
So just like Adam mentioned before, in some areas, we use the cellular network. Because the Wi-Fi is not very strong, so cellular is another way.
It's internal, but then, right, you'd have to have that conversation. All right, any other questions? All right.
Thank you. Thanks everyone. Thanks for joining.